Will caking properties increase during coking coal blending process? Yes, they will. For example, when we often blend two types of coking coal in a certain proportion, we find that the actual measured caking index, or G value, is higher than the theoretical weighted average. Sometimes this increase is quite significant. This is called the caking increase phenomenon. To fully explain this caking increase phenomenon, we need to start with the process of plastic mass formation for some theoretical discussion. The formation of the coal's plastic mass primarily occurs during the coal's first metamorphic jump. The coal's first metamorphic jump begins at a vitrinite reflectance of 0.6 and ends at approximately 1.3. The first substage is between 0.6 and 0.8. A considerable portion of algal matter or exinate components within the coal will transform into secondary vitrinite. At this point, the coal changes from non-caking to caking. In this stage, it's a rapid process of plastic mass formation. The coal stability is relatively poor. Then, from Rmax 0.8 to 1.3, this stage is a period of stable plastic mass formation during the coal's first metamorphic jump. During this process, the coal's oxygen content continuously decreases and the hydrogen content relatively increases. The side chains in the coal's original structure, particularly within the carbon structure, especially oxygen-containing functional groups, and so on, continuously shed. On one hand, the plastic mass continues to grow and caking properties continue to increase. On the other hand, this leads to a looser coal structure, a decrease in specific gravity, and an increase in porosity. In this process, the growth of the plastic mass reaches its peak when approaching a reflectance of 1.3. This process is essentially complete. At this point, the coal we typically see have a caking index of 100 and a Y value of 40. Particularly fat coal usually forms during this stage. The characteristic of coal in this stage is that when coked alone due to its structure and porosity and the excessive caking property in its active inert ratio, it can lead to coke size and strength, not reaching ideal results. However, it possesses excess caking capacity. Because when measuring the caking index, too much caking property cannot be fully expressed in the test result of the caking index G value. So it actually has a part of its caking ability latent. When we add another type of coal with poor caking properties into this system to blend with it, their combination will effectively adjust to make their active inert ratio more reasonable, fully utilizing the excess plastic mass. Therefore, the caking increase phenomenon will occur in this process.